Hey everybody, this video is to give you some examples that come from the Transformations of Functions classwork that is for one of your online days. So you can type it right onto your Google Doc. It says like click here, or if you want to just put these on a separate piece of paper, it does not matter to me. We're going to do a few of them together in this video. You will do a few of them on your own, and then the next time we Zoom, we will go over these. All right, so I'll do number one. By now, you should be able to identify that because we have x raised to the second power, this is quadratic. And so the parent function is x squared. So between the parent function of x squared and your new function of x squared minus 6, this minus 6 is a transformation because that's not in the parent function. So if you did the investigation and you watched the other video, you would know that that means it is a shift down 6. So that means your vertex has been shifted down 6. So I'm not going to sketch this perfectly, and honestly, you don't have to do anything on your copy with the graph. You should just be able to type this into a Desmos graph and see the transformation yourself. So that's it for that one, down 6. All right, question number 2. You should recognize the absolute value function by the bars that are there. So the parent function is the absolute value of x. So the fact that this equation has a minus 1 inside the bars and your parent function doesn't means it's a transformation. Inside with the x is a left or right, and it's opposite from what you might think. So if it's minus 1, that's actually going to shift it to the right 1. When you're telling me that a graph has been shifted, please make sure you include how many units it's been shifted. This way I can make sure that you're pulling the numbers from the right spot. So this would be an absolute value function, and the vertex is right 1 instead of being on the origin. All right, number 3, you should recognize as a radical, which the parent function would be just the basic square root. And with radical functions, it's important that you see how far the bar goes. This plus 4 is not under the square root sign. So that's like the K position on your little graphic organizer that was in the last set of notes. So whenever it's on the outside, it's an up or down shift, and since it's plus, it will shift it up 4. So that means your initial point for your square root or radical function is up 4 places from the origin. All right, and again, you can always just graph these in Desmos, or if you got a graphing calculator, and see that my sketches should be very similar. All right, number 4 has x to the power of 2. So you should recognize that as quadratic. X to the power of 2 is supposed to be there. So that means this plus 1 is a transformation, and the plus 3 at the end is another transformation. Inside the parenthesis is a left and right shift, and it's opposite from what you might think. So plus 1 is actually left 1, and that plus 3, any plus or minus at the end, is a shift up or down. So plus is up. So what this is going to look like is a parabola, but the vertex of your parabola is going to be left 1 and up 3 from the origin. All right, so the transformation form tells you where to put that either vertex or that initial point. All right, so what I would like for you to do before we meet again is the second page. So on your own, I would like for you to do the second page. I'm going to do a few now from the third page. So specifically the problems where you have to write your own equation. These can be tricky, and this can take some time to practice because a lot of times you know what it's supposed to look like in your brain. It's just a matter of getting it onto the paper the right way. So one thing that I will do to help you out is write down the parent function and what you're going to build off of. So absolute value, we're building off of the absolute value of x. Now you notice that I've left a little bit of space after the x. That's because if you have a left or right shift, it's going to have to go inside of the bars. So that's why I left a little space. Linear is just x with no powers. Square root, and if you have a left or right shift, did I say that right? Left or right shift, you would want to make sure that you put that under the square root bar. Square root and radical mean the same thing. Quadratic for the next two. If you're going to make your function quadratic, it has to have x to the power of 2. So I will do 10 and 13 with you. So absolute value, a vertical shift down 5. So this means I'm going to need to see a -5 at the end. And right 3, left and right is opposite from what you might think. So the right is actually going to be -3. Left and right is always inside. Up or down is always outside. So my equation is going to look like the absolute value of x -3 on the inside, -5 on the outside. And when I'm saying inside and outside, I'm referring to the bar or the parenthesis or the square root sign. Whatever symbol is kind of defining that function for what it is. All right, so number 13, I want to, actually I'm going to do number 14 for you. I want you to do number 13, so I'll do number 14. So by giving you the vertex, I'm telling you the shift. So if you have a quadratic function and this is the new vertex, I want you to think about where on the graph would you go to plot this point. You would go left 5 and down 2. That's where the point -5, -2 is. So by telling you where the vertex is, I'm telling you up, down, left, right, however you would normally get to that point on a regular piece of graph paper. All right, so left is going to have to go inside of the parentheses, and it's opposite from what we think it's going to be. So I'm going to set up my parentheses. I'm going to square it because that's what will make it quadratic. Left 5, I'm going to have to put +5. Down 2 is going to be an outside. Minus is down. All right, and again, if you need to, refer to the graphic organizer that I did in the first video and the Desmos investigation where you played around with what the different numbers did on the graph. All right, number 15 and 16 are multiple choice. So I will do a few on this page for you. And I'll do a few that I think you might need help with. Ones that we haven't quite done. So I'm analyzing these first so I can make sure if there's one that I think will be super, super tricky, but it doesn't really look too bad. All right, so I'll do number 19 since you haven't seen any square roots yet. So you're supposed to write your own equation. So since this is square root, this is the parent function that I'm building off of. If there's something to the left or right, I'm going to put it inside. Something up or down, I'm going to put it at the end. This has not been reflected because if you type y equals the square root of x into Desmos, you're going to see that it looks pretty much like that. That's pretty much going to be the parent function. So you can tell where my new initial point is. And with this, your initial point should be an actual point. So if it looks like it's a little bit off, just go ahead and draw it or imagine it going to the actual ordered pair. This graph is just like a little bit weird. All right, so this point is 1, 2, 3, 4, 5. 5 places to the left of where it's supposed to be. So that means I need a +5 inside the parentheses. And you don't have to type the parentheses. I just put them there because it keeps it consistent. But those two are the same thing. Just make sure when you're doing radicals that if you have a left or right shift, that your bar goes all the way across the plus or minus whatever corresponds with your graph. All right. So hopefully that gives you an idea of how you're supposed to kind of look at this page. For quadratics, your parent function was here. And so when you're describing the transformation, you are describing where the vertex is. It started on the origin. So however you get from the origin to the new vertex is your transformation. Same thing for this square root. This point here started at the origin. So how do I get from the origin to that new key point? With linear is a little bit tricky because technically you could shift it up, down, left, or right, and it would be in the same spot. So I'll give you those 2 points. Just use those 2 points. All right. And none of these have been reflected, and none of these have been stretched or compressed, and we can go over why that is when I see you on Zoom. All right, so try that. Come to Zoom with questions, and we'll talk about whatever misconceptions you guys still have.